Chapter 4 test. Okay, let's go over it here. We have compare the following investments by calculating the investment after 12 years, putting in $4,600 starting amount, compounded monthly. So we got to use the compounded formula. So that's the amount after some years is the amount at the start times 1 plus the interest rate divided by time, how many times it's compounded, and we got to multiply by this, the number of times it's compounded, and then times the number of years as the exponent. So the starting amount is 4,600, and we're going 100% of it's going to come back, plus the interest rate, 4.35 in percentage, but in decimal it's 0.0435. Compounded monthly, so there's 12 months in a year, so we're going to have to multiply by this 12 times to get a year, and then to get for 12 years we have to multiply by the exponent by 12 again. So this is what I got to figure out, and so I'm going to type it in my calculator carefully, hopefully, and get it to work. So let's see, put that there, put this there. It's not too bad a spot right there. So I want to do 4,600 parenthesis 1 plus 0.0435. That part is divided by 12. Close the parenthesis. Then I got to take it to an exponent, and I'll put it, on this calculator, I don't need parentheses because it's pushed up, but generally you want to put the parentheses on this, so I'm going to go parentheses 12 times 12. And I get that there would be, after 12 years, $7,745.50. Now, if I compounded continuously, well, that's a different formula, so we have to remember what that one is. It's on your note card, hopefully. It's the amount after so many years is the starting amount times 0 years, and it's e to the rate times the number of years. Starting amount, 4,600. E, interest rate, this is different than that one up there, so I have to put it in decimal, 0.0425 times, in the exponent still, the number of years, and we're doing 12 years. So I'm going to type that in. That works there. 4,600 e to the power, parenthesis 0.0425 times 12. And that's 766034. So which one has the greater balance? Well, this one did. It's a little higher interest rate, compounded monthly instead of continuously. This tends to be better, but this one had a higher interest rate, which made it worth more. And so it's better by the difference in these. So A, part A by, and now I got to subtract them, so I'm going to take the upper one, 77745.50 minus this last answer, and I get $85.16 better. exercise, taking this from that. What's the APY? Well, that means annual, so we want to go for 1 year, not 12 years, so that would be just this multiplier, 12 times 1 if you want to put a 1 there, but you don't need it. It's just going to be this multiplier, and that would be, tell me, all of it back plus the interest. But I want to know just what's the rate of interest only, so I'm going to type in that whole part, 1 plus, and the interest rate was 0.0435, compounded monthly, 12, to the 12, and I'll show you what that comes out to be. 1 plus 0.0435 divided by 12 to the 12. Oh, I typed in something wrong. Oh, I didn't have a parenthesis in the beginning. Insert a parenthesis. And that comes out to be this, which is all of my money plus 0.443 or 4.4375, this amount extra. That's called the yield. We want to get rid of the 1, which brings us the original starting amount. So we've got to subtract 1 from this. So I take this and go minus 1, and I get that in decimal. Change it to percent by going times 100, and the annual percentage yield is 4.44, rounded off, percentage yield. Okay, this one. So how much would we have to invest it at 5% for 10 years, compounded, so we've got to use the compounded formula, daily, so it's not compounded continuously, and ending with this. Okay, once again, the compounding formula, the amount that you end with after some years is the starting amount, 1 plus the interest rate divided by how many times in a year to the n times, you got to multiply it by this number of times in a year times the number of years. So let's put all the stuff we know. We want to end with 20,000. We don't know how much we're starting with, but we do know that this is 1 plus 5%, so that's 0.05, compounded daily, so there are 365 days in a year, and we have to multiply this 365 times for 1 year times the number of years, 10 years, and I can get this number, and it'll be times what I want, so I have to divide by this on both sides. On both sides. And so my answer is going to be 20,000 divided by all of this, and it's going to be 1 plus 0.05 divided by 365 to the 365 times 10. So typing that in on a calculator, it's going to be 20,000 divided by parenthesis. And I'm trying to group the whole denominator together, so I'm just going to put an extra parenthesis there. Parenthesis 1 plus 0.05 divided by 365. Close that part to this power, so to the power, and then I'm put my power in parentheses. 365 times 10, close parenthesis for the power, and then close parenthesis for the denominator. And it says I'd have to start with $12,131.03. $12,131.03. If I put that much in under these conditions, I'll end up with $20,000 after 10 years. How much would a savings account be if monthly payments are made? Oh, so we're making payments into a savings account. That's the third formula that we worked on. The amount after so many years is the payment you put in, the book called a PMT, times, and there's a numerator and a denominator that's a little bit complicated. In the numerator, it's that familiar 1 plus the, and I better put this in parentheses, the interest rate, which is 0.035, that's the R, over the number of times it's compounded. We're doing monthly, so that's 12. And this is always 12 times, same number here as here, times the number of years, which is 20. So we got 12 times 20 up there. And then we want to use the yield, so we have to take away 1 over this part right there, 0.035. The rate divided by the number of times it's compounded a month, in a year. There's 12 months, so it's 12. So we got to type this in with the payment of $100. So to type that in, we would type in $100. Now I've got a numerator, and it's all got to be enclosed. So I got parenthesis, and then in there's a parenthesis for the 1 plus 0.035 divided by 12 times in a year, because it's monthly, close parenthesis, and we got to multiply by this whole thing 12 times, so that's why it's an exponent, because we're going to multiply it by 12 times. Oh, and I want to put this in parentheses, 12 times, and for how many years? 20 years, so times 20. 12 times each year for 20 years. We have to multiply this. And then we want it to be yield, so we have to subtract that 1. That's real important. You'll get really crazy answers. And that's my numerator. I got a parenthesis for there, ending there, and 1 for there, and 1 set for the exponent. That has to be divided by this, and that needs to be in parentheses. Divided by parenthesis 0.035 divided by 12, close the parenthesis. And I get the amount that would be in this account, putting $100 in, getting 3.5%, 12 times a year, and for 20 years. And I end up with $334,686.10. Oop, period. 93 cents. Okay. So how much would you have to add to a savings account each week to have an ending balance of 10,000 after 5 years? So that's the same formula that we just did, only this time we're looking for this, knowing how much we want to end with. So I'm going to write that formula down again. That's the amount at the end of so many years is our payment, parenthesis 1 plus the rate divided by time. How many times a year? Number times a year times the number of years minus 1, close the numerator, divided by the rate divided by n. So we're trying to find this time so that we end up with 10,000. So we want to end up with 10,000. We don't know what the payment is. I drew the line under it, but it doesn't have to be. And this is going to be times all of this stuff filled in. So let me put that there. So it's going to be parenthesis 1 plus interest rate 6%, 0.06. Each week, there's 52 weeks in a year, so I'm going to have to multiply by this quantity 52 times for each year, and we're doing it for 5 years, so times 5 years minus 1, and that's all divided by this, the interest rate 0.06 over 52 weeks in a year. This times this makes this. So if I divide both sides by this, that would get rid of this, and I'd have it, this divided by this would be the payment, because this is times this. So I'm going to do 10,000 divided by parenthesis 1 plus 0.06 divided by 52 to the 52 times 5 years minus 1, and that is divided by 0.06 over 52, and this is all in the denominator, so I need another set of parentheses there. So let me show you how that would be typed into a calculator. So I've got the 10,000 divided by, now I got to put a parenthesis for the whole denominator, and then a parenthesis for the numerator, and then a parenthesis for this piece of the numerator. So I need 3 of them. 1 plus 0.06 divided by 52. That ends this inside parentheses. To the power, so I got to go to the, and then I want to put this in parentheses because there's 2 things there that are power, and we got to group them together. 52 times 5 years. Close a parenthesis. That's that power. Then I got to come back down out of the power on this calculator. Some of your calculators won't have to. But I got to go minus 1. That ends the numerator. So this was the beginning of the whole fraction, the denominator. This is the beginning of the numerator, and this is inside the numerator. So I'm ending the numerator, but I haven't ended the whole fraction yet, because I got to divide by that. So I could divide by 0.06 divided by we're doing this. Oop, and I forgot the parentheses on that denominator. Got to back up here. Parentheses 0.06 divided by 52 weeks in a year. Close the parenthesis. Now I finished the denominator parentheses. Now I got to finish the whole thing we're dividing by. So there's a lot there. Got to get all these parentheses in, and then you find out that you put over $33.00 in every week, and you'll have $10,000 after 5 years if you can get 6% interest rate compounded weekly or payments weekly. All right. Now it's saying, how long would it take to double this if it's compounded daily? Well, we're doing the compounded formula, not the payment formula, not the payment formula, the compounded formula that we had at the beginning. So we're doing that formula. So let me write it down. The amount at the end is the starting amount. 1 plus the rate divided by n. We got to multiply this n times for 1 year times the number of years. Now, if we start with 4,000 and we double it, this would be 8,000. Now, if this is 4,000 and it's times something and it's supposed to come out to be 8,000, this part without the 4,000 would have to be a 2. 2 times 4,000 is 8,000. So I'm going to go down here and say 1 plus my interest rate, 0.04 divided by daily, 365, to the power 365 times the number of years needs to be 2, so that this times the 4,000 will make the 8,000. So just this, no 4,000 or 8,000 here, as some of you did on the test, has to be 2. So now I've just got to guess on what that has to be. So I'm going to take my calculator and type in parenthesis 1 plus 0.04 divided by 365, close parenthesis, to the power, parentheses, 365 times the number of years. So I'm going to guess, let's try 15 years. Is that 2? Nope, not enough years. So let's increase the number of years. So I'm going to bring it back by second enter and go up here and make it 16 years. Still not 2. $4,000, yeah. Let's see. Let's go to 17 years. 17 years. Ooh, getting close to 2. Let's go to 18 years. That's more than 2. So it's somewhere between 17 and 18, which would have been good enough, but I'll continue looking here. I'll go 17.5 years. That's a little more than we need. How about 17.4 years? That's getting closer. 17.3. That's a little bit less. So it's a little bit more than 17.3, a little less than 17.4. 17.4 for sure. 17.3 is close.